You will be starting with a usual equation and you are asked to differentiate. But before you start to differentiate, I would like you to always consider to manipulate the equation. Before you even differentiate, let's think, should I transform? Can I change the equation to another structure? For example, in this question, I could ln both sides. I could have changed the equation to look like this first before I do any differentiation to second derivative. The question is, which should you apply? Do you go for the original or the new equation? You may need to judge based on the show. In the show problem, you see that there is an exponential appearing. So I will then want to actually start with the original equation and not this new one because of this particular term. But there will be question types where it's easier to use the manipulated form. Okay, so you will judge based on what you need to show. Okay, so part one, let's start this equation. We differentiate directly. So I say we differentiate with respect to x. My left-hand side, we have ey. You differentiate, you get ey dy dx. The right-hand side, we differentiate 2 is 0. You differentiate sine, you get cosine. You may want to check anything you can simplify. Do I need to sub back any from the initial equation? Okay, nothing we can do for now, nothing to simplify. So we go for a second round. Let's differentiate again. There's still a product of two terms. So you keep ey. We go for product rule. Differentiate dy dx, we get d2y dx squared. I keep dy dx. Be very careful. You now differentiate your ey again. Differentiate ey gives you ey dy dx. That's another dy dx appear. And on the right, we get negative sine x. If we try to match the terms, this ey on the left seems to be extra, but d2y dx squared and dy dx squared both should appear, and we had it. This last term on the right is the one that you have extra, you don't want. I don't want sine x to appear. So same thing, we should go back to the front equation to check where is that sine x. I could make sine x the subject from here to try to eliminate. It's a quick one, we will get ey minus 2. Always go back to the front to find terms for you to eliminate. Okay, so let's continue. Next line. We're almost there to get the show equation. We will just be dividing throughout by ey, and we can get the show equation. Ey is the extra term throughout. In part 2, which is the main thing. So they are now saying, can you further differentiate the result? Let's get this thing called the Maclaurin series expansion for y up to the term in x cubed. Now, can I change the problem a little bit? Can I just go for x squared so that we can just get the understanding of the concept quickly if we do less terms. Okay, what do they mean by Maclaurin series? What are you supposed to apply? Okay, let me write part 2 below here first. I would like to apply this following formula. Let me just copy it for the first time that we are doing it. Now, you don't have to write this in your exam because this formula is in formula list. But I just want you to know what I am going to do. So we are going to apply this formula. They said up to x squared, so I will only have 3 terms here up to x squared. The rest, you use dots to indicate. So a Maclaurin series can have any number of terms. It's a sum to infinity. But you write the number of terms based on the requirement of the question. Now, what are the values you need to find? We want to solve for f0, f prime 0, and f double prime 0. So where to get those values? We will start from the very initial equation. Okay, let me just work it out on the right-hand side. I am going to start substituting x is 0 to the initial equation. f0 means you want to find the y value. So can I just substitute to the original equation? We try to find the y value. Put x is 0 to the initial equation. So ey is 2, y is ln 2. Okay, next, I need f prime. F prime 0, go back to the equation that you have differentiated once. This is the equation where you start to have dy dx. You use this. X is 0. What is your y? Y you use back from the previous one that you have found. So you put ln 2 as y, but x is always 0. Okay, let's sub to that equation. So I will get e ln 2. The y value that appears used from the previous one that you have found equals to cosine of 0. So 2 dy dx. Remember, e and ln will cancel out. You get 1. So dy dx is half. Third number that I want to find is f double prime. So your d2y value. From this last equation, use the one that you have simplified or shown. Use this last one. So I sub in the values again. Let me just move it a little bit. So d2y dx squared plus, when you see a dy dx, like I told you, use from the front, the previous one. So will be a half square. I would like to be extra careful with the e and ln. If you have any coefficients appearing such as this negative, you should move it to the power first before you simplify. So it should look like ln 2 power negative 1. Okay, move the negative or any coefficient to the power of the log first. Okay, let me combine some of the terms. 1/4 I shift over. E and ln will cancel out. 2 power negative 1 is half. So if I simplify, we will get negative 1/4. So let's note all these 3 values that we have. These are the side working. I want to use this, dy dx, and my d2y dx squared. These are the 3 values that we will take to put into the equation. When we write the Maclaurin series, your left side will be your y. We are always finding the Maclaurin series for y. So let's sub in the values. I will get a ln 2 plus half x. F double prime 0 is negative 1/4 over 2 factorial.